Okay, we're here to talk about next generation network as code, a versionable database with a source truth. That may not mean so much right now, but let's move along. Okay, Tim, if you wouldn't mind introducing yourself.
I'm Tim Sehn. I'm the founder and CEO of the company that built Dolt. We'll be showing you Dolt kind of throughout this presentation, a deep demonstration of our capabilities. For that, I was the vice president of engineering at this company called Snapchat. Some people may have heard of it. And before that, I kind of grew up at Amazon. My last job was running the border network in AWS. And so a lot of the network configuration problems that we go through in this talk, are definitely not foreign to me. So I'll turn back over to Ken.
Hey, Tim. I'm Ken Celenza, Managing Director at Network to Code. I was a traditional network engineer by night, network engineer by day, coder by night. Always the scripting guy in the corner. I converted to full-time network coordinator back in 2016 when I joined Network to Code. And been in the industry over 20 years, starting out in the Air Force, working nearly a decade at McKinsey and at Network to Code over 4 years now. With that, we'll jump into agenda. We're going to first kind of look at the current state of source of truth, then kind of understand how to manage data like code, both in a quasi-traditional sense and what we're introducing, some technologies we're introducing during this demonstration. And after that demonstration, we'll just have a quick wrap up, talk about some features introduced here as well. All right, so the current state of source of truth. So why is source of truth so important, right? Configurations do not provide tracking. It doesn't tell you things like who created the configuration, why they make the change, when did they make the change. These are reasons why things like infrastructure as code have been introduced to help provide that, right? So infrastructure as code using version control systems such as YAML can help you actually provide this information, but configuration itself doesn't provide that. The data, as currently within infrastructure code, may do that, but again, not from traditional network engineering. It helps ensure consistency between when the data can be disaggregated from the configuration. If the only mechanism to introduce configuration is by merging those two components, the templates and the data, it really helps kind of, bring those two together, and there's no kind of other method to have that disaggregation from your intended state and your actual state. Configurations are not queryable, right? Even YAML, in a sense, like the newer generation of infrastructure code is not queryable. And that data is actually very valuable for various different reasons to answer questions like, where's my server connect to? Where does this IP address live? Who owns this IP address? And so forth. Data gives you the ability to document your network, provide reports on your network, auto-generate visualizations, and so forth. It's really kind of quite a powerful tool once you get to that point. Designs are intended to be consistent, reality is otherwise, right? And so we're kind of demonstrating here is a standard, or expected patch cabling schedule here. On the left is design, right? N number of N links or uplinks, N number of ESXi ports, N number of access ports. But the reality is things have to be, things actually get implemented very differently, right? And so your data model needs to be flexible, whereas your design can't always be as flexible, and it helps you disaggregate those two components. Why is managing a source of truth so difficult, right? First and foremost, this is just the volume. There's absolute massive scale that's associated with kind of network infrastructure in particular. There's literally potentially millions of data points, even if you just consider just interfaces in a YAML example, right? Just converting a configuration to YAML could just be managing millions of lines of that data structure. Standards are possible to enforce, things like naming standards as things change, lack of ruthless standardization overall. There's no staging. Really what that gets to, that feeds into the next point, which is there's no staging and thus no ability to test that. Trust is hard to gain with data, but it's easy to lose. The most common response I'll often hear is, I just look at the configuration when I need to know something. I never trust the source of truth. So quickly, I want to go in through what the current source of truth lifecycle looks like when you're updating via a database. If you update your data before the change, your data is out of sync until you actually run that change, right? So you kind of break one of the tenets of a source of truth, that the intended state is supposed to always be in sync with the actual state. And that's just not happening there, right? If you do it during the change, you can prepare as much as possible, but you have no test and you have no assurance that the change is going to be successful. So you can run into issues then. And honestly, it's usually the last thing during a change which you're worried about fixing and updating. So it gets left off. And similarly, if you update your source of truth in the database after the fact, it's once again, it's out of sync until you get to that, if you do actually get to it. And with that, I'll hand it over to Tim.
Thanks, Ken. I'm going to talk to you all about how to manage data like code. So when we're talking about managing data like code, traditionally we have two tools that we think about in this space. The first is Git. Git is the standard source control versioning system for the last 10 years or so. It was released in 2005, invented by Linus Torvalds, the guy who wrote Linux. And since then, it's kind of been on a warpath and became the standard for distributed version control. It's an interesting model where you can distribute files and branch and merge. And the kind of key characteristic that differentiates it from source control that came before it was the ability to have a sort of an infinite number of branches given its commit graph storage structure. And so the second tool that we talk about when we want to manage data like code is databases. And so databases generally back applications. When we're talking about network configuration, NetBox is backed by a Postgres database. Databases allow you to query large volumes of information, whereas like a file-based system, such as a YAML-backed configuration store, wouldn't allow for sort of complex UI and querying that you're able to get with a MySQL database. And so what we've done is we've combined those two concepts, Git and MySQL, and we've made a tool called Dolt. So Dolt is kind of a strange name for an infrastructure tool, but we have an explanation. We wanted to pay homage to Git. Git means idiot in British slang, so we needed a word that meant idiot that was short enough to type in the command line that started with D for data, and thus Dolt was born. And so I'm going to spend the rest of my time explaining to you how Dolt works and how it applies to this use case. So Dolt, just think Git plus MySQL equals Dolt. It's as if these two technologies had a baby, a beautiful one. The goal of Dolt is to support 100% of Git operations and 100% of MySQL SQL, and then invent SQL to be able to do the Git operations in SQL natively. So think, how would I run a commit or a diff in SQL? And so we've made a ton of progress. We released Dolt open source a year ago in August, so we're a little over a year old. We support about 90% of Git operations. We support about 93% of MySQL SQL. The Git operations we don't support are things like rebase. For MySQL SQL, we don't support window functions, some sort of advanced SQL topics, but we'll get there within the next year or so. And then we have on the agenda of inventing SQL to do Git operations, for reads, we have system tables for logs and diffs. So you have queryable diffs. And then for doing writes, things like branching and committing, we have SQL functions to do those things. And so we're kind of getting there. We also built Dolt Hub. Dolt Hub is a place on the internet to share Dolt databases. And so Dolt Hub provides standard GitHub functionality like pull requests, webhooks to integrate your continuous integration, forks, permissions, all the things you've come to know and love with GitHub. So now I'm going to talk a little bit about infrastructure as code using the current design. So if you look at this slide, this kind of illustrates a standard infrastructure as code backed by a YAML store and Git. So this is where you would stick your YAML files in Git, push those up to GitHub when you make a change, have a webhook doing continuous integration, and then do a merge via pull request. This will look really familiar when we go to our infrastructure as code design using Dolt, because Dolt is sort of a drop-in replacement for Git, but instead of being files, it's a database. These pictures look pretty similar. And so in this case, we have NetBox backed by a Postgres database. That Postgres database is synced to a Dolt instance. When you create a branch, we replicate the Netbox instance and the Postgres database, and then sync that to a different branch in Dolt. Dolt is then pushes to Dolt Hub whenever we make a change, and then we execute webhooks when we do a pull request, and then once that pull request is approved, we push that back up to the production database using a custom feature in Dolt called Dolt Diff. So Ken's going to walk you through this in great detail. And so I'll hand the presentation over to him to show that to you.
Okay, great. Let's get into the demo here. I'm going to log into my Netbox instance as my own user, which is just simply Ken here. And what we'll notice here is a few different things. One is that this user does not have any edit rights. And if you're familiar with Netbox, you would be used to seeing icons here. But don't worry about that for now. For now, we'll show you and compare it in a slide or two, or sorry, a second or two. And the other thing you'll notice here is that you have this plugin available here to do some Dolt get DB actions, right? So what would be tasked here in this change management, CM here, is to make a few updates to different VIPs here. So as we already stated, you can't make any edits as this user, but what you can do is add a branch. So I'm going to add a branch called CM for change management 1460, we'll call it. All right, great. And so on the right side of the screen here, you can see that I have the workflow kind of mapped out here, and we'll take you step by step each step of the way. So what just happened here as I committed that branch here is that there was a replication process, and that process did a few things. One, it replicated all the Dolt DB data, all of the Postgres data, which Netbox is backed by Postgres, right? And it created an entire new Dolt instance, right? Create an entire new Netbox instance, which is shown here, right? And this will indicate which Netbox instance is associated with each branch, right? And we can go to both of our new Netbox instance as well as our Dolt Hub instance, and we'll get back to that as well in a short time. The first thing you'll notice when you get into a new Netbox branch instance, which is just a completely new Netbox instance, is this giant red lettering indicating what branch you're on, right? The second thing you're going to notice is that you do get those icons, right? And if we kind of go back and compare and contrast here, we'll just remember these icons do not exist because you do not have the edit rights associated with them. All right, so let's get into the actions that we want to have during this change management process. So let's do 3 different actions to kind of represent the CRUD operations. The first thing we're going to do is we're going to edit this VIP, right? So we're going to edit the Kenobi VIP, and we're going to remove the VRF management. That didn't really make sense. We're going to more formalize the description and make that update. The next thing we're going to do is we're going to remove the Calrissian VIP, right? Delete this completely. And then finally, we're going to create a new VIP, which will be the Skywalker VIP. And I'm going to make it a role VIP, and I'm going to call it Skywalker. Now, I'm purposely not going to include an FQDN here. We'll demonstrate why in a bit as we get through our testing strategies. Okay, so let's pause here for a second and review the updates that have happened to the database and thus the user interface here. So as we refresh on the branch, we'll note a few things about the data. 1, Skywalker has been added. 2, Calrissian is no longer there, and the modifications have in fact happened to Kenobi, as you would expect in any Netbox edit. However, more interestingly, in the production master branch instance, none of that information has happened because, again, it's on a completely separate branch. All right, so once we make our change, the next thing we need to do is actually commit this as you would in your normal Git operations. So we're going to synchronize this, and of course, as you would in Git, you do in Dolt, provide a commit message and say, updates for Interop demo. Okay, so what's happening here is the NetBox's backend is a Postgres instance, and Dolt is based on MySQL dialects, right? So first thing that we have to do is synchronize between the two and kind of convert that dialect from one to the other. Then immediately after, and it's already happened in real time, is a synchronization push, similar to a Git push. There's a Dolt push up into Dolt Hub. So now Dolt Hub has been updated with the new data that's been inputted. The next thing we can do is kind of see and review that and create a pull request for within Dolt Hub. So we'll give a quick refresh here. And you can, interestingly enough, you can view everything within the database here directly in Dolt Hub, but we're not as interested in that right now. We are interested in seeing a few things. One is the commit log, and we can see that it matches and time-wise matches. This was just committed, just as you're used to in Git. And the second thing we want to do is we want to create a pull request. So our change management into master, we will make a update for Interop pull request. Great. Now we can see within our pull request, we can see the diff here, which is pretty interesting actually. And Dolt Hub does a really nice job of visualizing what's been changed. So we have three different things going on. The white columns are for edit with the red and green lettering to indicate the adds and removes within there. So Jedi Council became Jedi High Council and the VRF was changed as an example. The red rows were removed and the green rows were added, right? So we removed Calrissian and added Skywalker in there. Great. The next thing we're going to go through is Dolt Hub actually during commit created a webhook to a running Jenkins instance that I have up ready to receive this webhook. And we'll see, and unfortunately, but expectedly, the test and CI testing failed. And if we scroll to the bottom, we could see that it's running tests, and we could see that it failed specifically on the VIP with the DNS name of Skywalker, which does not have an FQDN of ntc.com. This is a very simple test for a very simple demo. However, you could make tests for anything that you want, right? This is just the beauty of CI systems is building tests, and you could model this data in other environments as you so desired. So in order to remedy this failure, we need to update the tests or update the data so that the tests pass as you would in Git. So we will go back here and we will update this data. Once again, we need to synchronize this. Say fixes for Skywalker. Make that update. Okay, great. So at this point, it's going through that same process we saw before, which is a resync all the way through Dolt Hub, the Postgres to MySQL dialect change, and then push to Dolt Hub. This, once again, will rerun a job in Jenkins, and we'll get back to that in a second. But before we do that, I do want to show, didn't think it would be as interesting to show just one job going. I want to show multiple branches kind of going, competing with the same or different data, just the same way you would with Git. So you could have two different branches, a second branch committed before that first branch in reality. So in the interest of time, we're going to make an update here within our master branch on the NTC user, which has admin privileges and can push directly to master, which of course you should never do, but in interest of this demo, we shall. And what we're going to do is change the corp status on smugglers from LLC to Inc. And then once again, synchronize and push this. So Okay, and again, of course, this is going to push directly to Dolt Hub from master all the way through, which is, again, not following best practices, but we'll demonstrate um, that we can have multiple changes happening at the same time, all coordinated by Dolt. And so if we review here, we can see that the branch is as expected with skywalker.mtc.com. Master now includes incorporated, but none of the changes that we put into the branch. Right. So during this process, another commit happened, and we'll go back to our Jenkins instance and see that yes, we passed the first part of it, but we have not passed the second. The next part is a manual approval. This is currently a two-step process based on the way Dolt Hub sends webhooks. And the one step, and my good friend Tim over there is going to approve my pull request, which is currently just just a comment that you leave in the Dolt Hub, and we orchestrate it. So if I refresh, I see that my good friend Tim actually did in fact approve it, which means when I go and release the gate from Jenkins, we will orchestrate the entire change, which means doing everything from updating Dolt, local Dolt, updating the SQL on the master, on the production instance, and all of the Dolt actions that are required in between. So I will go ahead and do that. And we can watch the test passing real time here. And this process takes but a minute or so. And as always, the CI any CI system rerun the tests to ensure that everything is still in the same state. And what we can see here, yeah, it's running tests right now. We can see the data that's about to be pushed in both SQL format and more readable table format. And what you notice here is things like the smugglers. Any of the smuggler incorporated changes are not actually here. As an example, we see that Calrissian is being removed and all the changes that we expect to happen. But we're merging between two different branches here. We're not just comparing one branch to another and making one branch look like another. We're actually merging between commits. That's the technology that Dolt has for databases that are normally kind of only seen in Git. All right. And the SQL has actually been updated, and now we're just finally updating to Dolt Hub, which will complete the merge request as well. And if we go back to our production master branch, again, master branch, we see everything is as expected. Smugglers Inc., Skywalker has been added, Kenobi has been updated. And then finally, if timing works out correct, when I refresh here, I should have a merged pull request. And there we go. That concludes the demonstration showing end-to-end workflow of a versionable database backed by a NetBox instance. Thanks.
Thanks, Ken. That was a great demo. It really showed off how version control can change the game in network configuration. The ability to make an emergency change on master while also having a CM going is something that would have saved my butt a bunch of times in one of my previous lives. So hopefully we can get this adopted throughout the network engineering community. So that didn't just work out of the box. Ideally, we would have migrated NetBox directly to Dolt as the backing store, but we scoped that project. It was about 4 to 6 weeks of work. So instead, we built a SQL sync utility. That's what Ken showed off when he was clicking the sync button. That takes the PostgreSDB and basically puts it in sync with Dolt. And so we spent some time building that for Ken. And then we also had to sync back from Dolt to Postgres. And so that's something we built, a technology we built for this demo. Early on, Ken wanted to show off CI. And so in order to do that, we had to build Dolt Hub web hooks. And so we shipped that in the summer, a little, maybe spring more like it. And so that was also shown off in the demo. So it's been a great partnership. Thank you to Ken and Network to Code for sort of putting the project the product through his paces. Dolt's a better tool because of that. So we really have a lot to thank Ken for. So with that, I'll hand this over to Ken to wrap it up.
Great, thanks, Tim. I like to think it was a collaborative effort, of course, that we both came to the conclusion. But I appreciate all the efforts you put into this as well, of course. So just real quick, so the challenge lesson learned. Building a non-integration solution actually took several steps just make it look, I'll say in air quotes, naturally. It's just converting Postgres to MySQL that I like. That obviously was going to be no easy feat. It's just in multiple technologies, and the amount of technology was just a lot. One of the things that actually was really, really awesome is having access to a GraphQL API. It was really, really great. It actually saved my butt engineering-wise a few times. So it was awesome, and great technology from Tim and company. And with that, I'd say, if you want to build something similar, reach out to us, and Tim or I to understand our different aspects and different capabilities that we can offer. And included are some links and information. There's blogs and our information all around listed there as well. And I think that's all we have. Thanks.
Thank you.